everyone going? Yeah, awesome. I'm Taylor. I'm from the University of Sydney, assuming I'm still employed after this. And I'm really excited to talk to you about what I do in my postdoc with Barbies, Swifties, and food security. So I'm a scientist. I'm actually a protein engineer, which my dad likes to remind me isn't a real engineer. And I do want to clarify something really quickly. So as a protein engineer, I'm actually not here for the gains. So when I talk about protein, a lot of the time people imagine this, which is not what I'm talking about. These are only little pieces of protein that can help you build muscle. I'm actually talking about this little cutie right here. This is an actual protein, and it acts as a sort of machine and somewhere in your cells doing some kind of function to keep you alive. And as you can imagine, in my line of work, I do have to have this conversation often, which has gotten me into some really interesting situations in supplement shops. And my whole field of protein engineering actually falls underneath a larger field called synthetic biology, which is basically the chaotic love child between biology and engineering. So we take engineering principles, things like design, build, and test, but instead of applying those to things like buildings or bridges, which my dad says would make me a real engineer, we instead apply them to things like DNA, proteins, and microorganisms. So often, synthetic biology is used to make really sustainable products. So we can program yeast and bacteria to produce things like fragrances, so you don't need to crush a whole field of flowers just to feel good about yourself. Or spider silk proteins to make textiles more sustainable, and because it's preferable to produce yeast at an industrial scale rather than spiders at an industrial scale. Although spiders at an industrial scale is how my American family views Australia. And in addition to making really cool products, synthetic biology can also help just improve normal biological processes, like the one I work on, which is photosynthesis. So you've probably heard of photosynthesis before. If you haven't, you've probably mentally blocked it out for some reason. But basically, it's the way that plants take sunlight and carbon dioxide and produce sugar that they can use for energy. And this process is super important, because without it, what would the vegans eat? I know that's a really risky joke in Newtown, but I'm feeling kind of spicy. So this tall drink of water right here is not Ken. It's actually a protein called ribisco. And he kickstarts the entire process of photosynthesis by doing a really important chemical reaction. So he takes carbon dioxide, then pulls out his little chemistry set. I'm not a chemist, I just assume this is how this works. And produces something that's almost a sugar. So he really kickstarts this entire important process. And as a result, ribisco is actually one of the most important proteins on the planet, and not just to the vegans. Unfortunately, Ribisco kind of missed the memo on that one, and he has quite a few problems. So one of those problems is that he's really slow. So while most proteins can do a reaction like 1,000 times per second, Ribisco does its reaction like 5 times per second, maybe 10 if he's feeling frisky. The other problem is something called selectivity. So he's supposed to react with carbon dioxide, but sometimes his eyes begin to wander, and he instead reacts with carbon dioxide's much more attractive, younger best friend, oxygen. As you can imagine, this causes a lot of problems. So much so that Ribisco's bad behavior actually creates a bottleneck in growing plants and in producing food. But it's not Ribisco's fault. I mean, way back in the day, a couple billion years ago, the atmosphere had a whole lot more carbon dioxide, and so Ribisco was a stud. There was no selectivity problem, there was no slow issue, there were no problems at all. He was the captain of the football team, he was the student body president, his parents bought him a really cool car. But much like that guy who peaked in high school, Ribisco is really struggling to cope with the demands of modern life. And he's pretty much the worst employee of the month every month. But you can't get rid of him because that reaction he does starts photosynthesis. It's super important. So what do you do when you have a shitty employee that you can't get rid of? You make it someone else's problem. So maybe you give him some kind of teammate that can compensate for some of his misgivings. And there happens to be a really good candidate for Ribisco's teammate. And her name isn't Barbie, it's carbonic anhydrase. And she's better than you. So while Rubisco is slow and easily confused, carbonic anhydrase is fast. She's focused, she's hydrated, she's thriving, she's in her lane. Carbonic anhydrase wakes up at 5 a.m., journals, meditates, somehow runs to the gym while also drinking a green juice. Carbonic anhydrase doesn't write a to-do list, she writes an is-done list. Carbonic anhydrase's dad thinks she's a real engineer. Thank you. But there's actually another reason why carbonic anhydrase is such a good candidate for a teammate, and that's because she also does a chemical reaction that actually produces carbon dioxide. And she can do this reaction up to 1 million times per second. Now, I've become very aware that I've assigned genders to these proteins in a very specific way. I'm not going to unpack that now. We don't have the time. I prefer to make my therapist work for her money. So algae, in their infinite wisdom, have already figured out that this relationship between Rubisco and carbonic anhydrase is a really good one. And so they've made this thing called a carboxysome, which kind of sounds like the villain's lair in a bad superhero movie. But in actual fact, it's a protein shell that is stuffed with copies of Rubisco and carbonic anhydrase. So carbonic anhydrase is doing her thing, producing tons and tons of CO2, and Rubisco is sort of trapped in a confined space where it's forced to make better decisions and actually start photosynthesis. It's a bit like taking someone who doesn't like Taylor Swift to the Eras Tour. They're in a confined space where they're forced to make better decisions. Just like to look at it, because thanks to Tic Tac, this is the closest I'm getting to the Eras Tour. Thank you, I feel seen in a way that's very healing for me. So, Rubisco sucks. Carbonic anhydrase is amazing. Carboxysomes put them together, and as a result, algae see benefits. Photosynthesis is actually more efficient. So why can't we take these awesome carboxysomes and put them into plants? And the answer is that carboxysomes are really complicated. So that protein shell I was talking about actually has like a zillion different components, and it's too hard for plants to make by themselves. So this is where my project started, and my mental and emotional well-being really declined. So I'm trying to make a simpler version of a carboxysome. And as you might have gathered, I am a Swiftie first and a scientist second. So I'm calling it the carboxysome Taylor's version. So a lot of the problem with the carboxysome is that really complicated protein shell. But it turns out there's actually a bunch of other protein shells that are a whole lot simpler, like this little cutie right here, who gets together with 239 of its best friends to form this, which I know looks really complicated, but it's actually a really simple protein shell that we know we can make in a bunch of different organisms. So you add some Rubisco, some carbonic anhydrase, and you get a simplified version of a carboxysome that we can engineer to be compatible with plants, or the carboxysome Taylor's version. And so right now I'm working through a bunch of different iterations of design, build, and test to try to make this thing the best we possibly can. Because ultimately, by 2050, we need to double our agricultural productivity just to keep up with our population. And we need to do this in an unstable climate, which means that we need new solutions to make sure that we all have food to eat. So I hope that I've shown you that synthetic biology can go a really long way to making sure that we have a secure food supply for a long time to come. And I think that's amazing. I'm engineering proteins to do exciting things and solve big problems. So you know what? Suck it, Dad. I am a real engineer. Thank you so much.
Let's give a round of applause for Taylor.